Hi everyone, I am Rajesh Kumar, Assistant Professor, Department of Computer Science, AJK College of Art and Science. Today we are going to see the topic about software design and testing. So the software design is a process to transform user requirements into some suitable form which help to the programmer, software coding and the implementation. For assessing a user requirements, we are using the SRS, that means a software requirement specification. So that document is used to finding what are the requirements given by the customers. So and the clients is what are the things they are required, everything will be documented in the SRS. Then the output of this process, that is software designing. Output of the software designing process, they can directly be used into the implementation in the programming language. Then the software design is the first step of the software development life cycle. That means we are already completed the software requirements and the analysis phase in the starting stage. There will be, we are collected all the details, what are the requirements given by the clients. That detail will be documented and it will be created as a software requirement specification documentation that will be used to go into design a software. Then after this completion of this step, then we will start with the software development life cycle concept, that is a designing thing. It tries to specify how to fulfill the requirements mentioned as in the SRS. Then it shows some diagram. The diagram is used to know what are the principles we are using for the software designing. There will be what are the specific method for the software designing we are using and what are the types of software we are going to design. Everything will be completed in this diagram. The next topic is software designing levels. So we are having certain levels for designing the software. The first level is the architectural design. The architectural design is the highest abstract version of the system. It identifies the software as a system with many components interacting with each other. In this image shows software designing principle. So in this image we can able to identify few points. It's commonly used for software designing. So what are the principles we are following for design the software? That will be commonly used things will be stored in this image. Next one is software designing levels. We are following a different type of software. We are going to design a different type of software. In that things we are following certain designing models, designing levels. The first one is architectural design. The architectural design is the highest abstract version of the system. It identifies the software as a system with many components interacting with each other like a modules. So each module will be connected one to one. So like R1 to 1, 1 to many, like that we are connecting. That thing will be combined and shown as a software. At this level, the designer get the idea of the proposed solution domain. So what are the requirements given by the customer, that will be we can able to finalize. Next one is a highest level design. The high level design is break a single entity multiple component, like a concept of architectural design into less abstracted view of subsystem and modules and depicted their interaction with each other. High level design focus on how the system along with its application, the components can be implemented in the form of module. So that will be created as a module. That module will be connected one to one or one to many, like that. So like a coupling, and the coupling concept, loosely coupling and highly coupling is that. That coupling we already know about that, how the modules will be connected. It recognizes a modular structure of each subsystem and their relation and interaction among each other. So there will be, we can able to know what are the things is there, like how the modules will be connected one to another one. Then the high level designing concept, it's shorted as a shorted word we are called as a HLD. That means a general form of a high level designing thing. So we going to design the software is high level. It indicates the description of the system architecture, database design, brief description of the system and the services, platforms and relationship among the object. These are all included in this high level design. So when we are choosing this design, we can able to easily identify lot of things as a proper documenting. Next one is a detailed design. Detailed design is a deals with the implementation part of what is seen as system and the subsystem in the previous two designs. So it's more detailed toward module and their implementation. How the module we going to design and how it will be connecting each other. Like that we are going to see this detailed thing. Next one, it defines logical structure of each module and the interface communication with each other module. So like that. So how the module is connecting with each other. So that detail, how the logically it was structured for connecting the things, that will be clearly given in this detailed design. Modernization is a technique to dividing a software system into multiple discrete and independent modules which are expected to be capable of carrying out tasks independently. Like that, as a big software, like a big software system is, we are splitted as a modules. That module is called as a here modularization. These module, many work has been basically constructed for the entire software. So small unit will be splitted. That module, that small unit will be combined together as a module. So each module is connecting with that thing, and the final thing will be getting a software. Designer tends to design modules such that they can be executed and or compiled separately and independently. So after the compilation, the designer and the testing team will be checking whether this module is working properly or not. So after this proper testing, then they will be connecting with that each other modules. So this is a thing in the module. Now we get some small image for the how the module will be connected. In that module, control module. That control module will be connecting all the modules, sub modules like that. It will be there. So some of the projects we are having a library modules. In that library module, it will be stored existing files, existing contents, existing some demo things. Everything will be stored in the library module. That library functions we can able to use in sub modules. So and these are controlled by the control module. This is a small image. It will be we can able to understand how the module is structured. Next one is the advantages of modularization. Smaller components are very easy to maintain, very easy to test. These are all some of advantages. Program can be divided into based on functional aspects. So we can able to easily functional aspect, we can able to split a huge project into smaller unit. So desired level of abstraction can be brought in the program. Component with high cohesion can be reused again. Concurrent execution can be made possible. Desired form security aspects. So we can be having a lot of advantages when we are doing with the modularization. Next one is the concurrency concept. This will be some different concept when we are coming with the modularization. Modularization it will be like an offline project. Concurrency is coming into the online project. The concurrency process, we can changing the software each and every time. So like that online projects, we are changing the each and modules and module components, like that we are changing simultaneously. So like that, so we are using that concurrency thing. Back in the time, all the software are being by the executed sequentially. By sequential execution, we mean that code of instruction will be executed once after another, implying only one portion of program being activated at any given time. So like that, when we are using with the website, one tab will be opened, another one tab may be created, but the coding is not created. but the first tab will be working properly. So concurrently live project will come like this much. So automatically we can able to get it what are the things in the first tab, but in the second tab it will not shows any content, but it will shows only the title. So concurrently they will be doing and they will be coming into the live modes. So this will be coming for the live projects, concurrency method. Next one is the characteristics of good software design. So we are following a lot of models, we are following a lot of ideas to design the software. So first we need some basic characteristics for good software design. A good software design can vary depending on their application being designed. For example, the memory size is used by the program may be important issue to characterize a good solution for embedded software development, since embedded applications are often required to be implemented using a memory limited size due to cost, space and power constraint. The characteristics are listed in the below points. First one is correctness. A good design should implement all the functionality identified in the SRS document. So what are the things customers are required, clients are required, that everything will be properly created and properly implemented thing, that is a correctness. Next one is a understandability. So a good design is easily understandable. Then only the users and the clients will be coming again and again for a new projects. So that is more important. Next one is efficiency. Efficiency, already we know about efficiently our document software have to work. And maintainability, it will be easily maintainable. We can able to change like that. We can able to design like whatever changes we want, we can have to do that. So the correctness is first of all, we go into detailed discussion about this characteristics. Correctness. First of all, the design of any software is evaluated for its correctness. So what are the, because we are the customers are required few things that we have to fulfill the software through the software. So we have to check with whether it was completely implemented or not. So the testing team will be checking what are the things the clients will be asked, that will be checked in the correctness thing. The evaluator checks the software for the every kind of input and the action and observe the result that the software will produce accordingly to the proposed design. If the results are correct for every input, the design is accepted and consider the software produced according to the design will function correctly. So what are the things we are given an input that have to properly produce output. So then we can able to understand that software is properly designed, that software is correctness. Then understandable. So what are the things there will be displayed in the software? Like for example, it will show a file save. So we can able to understand that concept is used to saving the document like that. So whatever software we are designing, that software should be understandable. This is because the hundreds or thousands of developers that are developing different modules of the software, and it would be very time consuming to explain each design to each developer. So what are the things we can able to design? Why there lot of team members are there? So each and everything we can't able to explain. So when we are seeing the thing, projects, that time the clients or the user can able to understand. Then only we can able to give a properly giving a projects. Then efficiency. So what is the expectation of the customers? Okay, what are the calculations they are doing? So everything we have to properly design in the software. So then only we can able to get it efficient values. Hence, for all efficient and good quality software to be developed, care must be taken into the design phase itself. So what are the things where they will be doing? Everything will be checked within this efficiency thing. Each and every values will be given as an input and checked whether it was properly working or not. So like that we have to design a project modules. Next one is a maintainable. Already I told with that. Maintainable concept we can able to modify in future, we can able to modify or something content we have to add or we have to remove, like the changes These type of changes we have to add and we have to do quickly, or we have without any modification. We have to add, means that software is good maintainable concept. We can able to call it as a good maintainable concept. So that is the thing in the maintainability. It should not be case that after making some modification, the other feature of the software start misbehaving. Some of project it will be coming there. So we have to do like a project, whatever things we are changing, the original software activity will not be changed. So that type of thing means your software is good quality level. So this will be already we have discussed about that. Next one is a completeness. The completeness means what are the things the project clients is asked, that details we have to give properly. That the data structures and module, external interface, everything we have to complete in the proper way. Next one is a maintainable. Already we discussed about the maintainable. Next one is a thing coupling and the cohesion. When a software program is modularized, it task divided into several modules based on some characteristics. So on huge projects, we are getting a projects from the clients. That project will be split as a small unit. That unit is called a module. That module will be working in this coupling and cohesion concept. As we know, modules are set of instruction put together in order to achieve some task. So it will be grouped as specific task completion. So that will be created as a module. That is a characteristic. Some characteristics will be matched with for the completing the task. They are thought considered as single entity but may refer to each other working together. This image will be getting a cohesion and coupling details. This image, first one we are going to see the coupling. Coupling means module to module interaction and module to module dependency, module to module connectivity. Like that, this will be deals with only that coupling concept. Next one, cohesion means inside of the module, how the small unit will be integrated, how the small unit will be depending for the other module, how the data will be connected, how the argument will be passed to one class to one function to another one function. Like that, we are going to deal with Dept. That concept is a cohesion concept. They are measured by which quality of design of module and their interaction among them can be measured. The measures are called coupling and the cohesion. So we already know about things. So we are having the module small unit A, B, that is a small unit in the module A. Then module B, we are having a small unit C, D, E. That component will be connected each other. That things will be called as a cohesion. Coupling means we have to connecting with module to module. These things will be discussed in the coupling concept. And now we are going to see the topic of cohesion. Cohesion is measured that define the degree of interdependability with elements of module. The greater the cohesion, the better in this program design. So we have to more cohesion is better to good software design. There are 7 type of cohesion is here. First one is a coincidental cohesion. It is unplanned and random cohesion which might be result breaking the program into smaller models for the sake of modernization. Because it is unplanned, it may sow confusion to the programmer and it generally not accepted. Next one, logical cohesion. When a logically it categorizes the elements or put together into a module, that is called a logical cohesion. Temporal cohesion. When an element of module are organized such that they are processed a small point in time, it's called a temporal cohesion. Next one is a procedural cohesion. When element of module are grouped together which are executed sequentially in order to perform a task, it's called a procedural cohesion. Next one is a communicational cohesion. when an element of module are grouped together which are executed sequentially work on same data, it's called a communicational cohesion. Next one is a procedural cohesion. When element of module are grouped together which are executed sequentially in order to perform a task, it is called a procedural cohesion. Next one is a thing is procedural sequential cohesion. The sequential cohesion, we are using the sequence of ordering the inputs and we have to check with that in between that module thing. Next one is a coupling concept. Coupling is measure that define the level of interdependability among the module of a program. It tells at what level of module interfere and interact with each other. The lower level of the coupling is better to the program. There are 5 levels of coupling, namely here. First one is a content coupling. That content coupling, when a module can directly access or modify or refer the content of another module, is called a content coupling. The module coupling is that small module will be having that module is not connected, that is uncoupled, no dependency is there, no module will depending on another one module. Next one is a loosely coupled, that will be some dependency back there in module to module connectivity. Then highly coupled means the module will be having connecting with each other more things. So low level coupling is more important to design a good software. Common coupling, when a multiple module have read and write access to some global data, it is called a common or global coupling. Control coupling, 2 modules are called control coupled if one of the deciding the function of the other module or change its flow of the execution. Next one is a stamp coupling. When a multiple modules share common data structure and work on different part of it, it's called a stamp coupling. Next one is a data coupling. Data coupling is when a 2 modules interact with each other by meaning of passing the data, that will be data coupling. If a module passes data structure as a parameter, then receiving a module should use all the components. Ideally, no coupling considered to be a best. Next one is a design verification. After the designing of these things, module and the connectivity of module and dependency about the module, everything is finalized. After that, we are going to check with a verification. The output of the software design process is designing a documentation, pseudocode, detailed logical diagram and process diagram or class diagram, UML diagram, like that it will be coming there. So there will be, we can able to understand what are the things they will be completed. This is the topics we are completed in the software designing level. After the software designing, we have to create a software testing cases. Software after that design, we are going to create a coding. That coding will be checked with that module. So that's why we are deeply discussed about the cohesion and the coupling. Next, we are going to cover with the software testing. After the software design, we are created as a coding, and then we will be checking whether the software is completed the client requirements. So small image for the software testing. So software testing is a basic process of verifying the system with the purpose of identifying any errors or gap between the SRS and the real software and missing the requirements versus the actual requirements. So these are all deals within the software testing, and few another definition we can able to say as a broadly categorized into 2 things. One is a functional testing and another one is a non-functional testing. That functional testing means it will be deeply discussed with the coding, and then non-functional means it will be deeply discussed with the designing of the softwares. Here are the top reason why we are doing the software testing. why we going to do the software testing? What is the purpose of the software testing? We have some points. First one, it will be help in saving money, because once we are completed the software, we have to check it. Otherwise, when we are completed software, we are deliver the software means the clients may be getting some errors. We have to again rectify that. Again and again we have to do the corrections. So these cost is much more waste. So we have to reduce that money thing. The cost effectiveness of the project happen to be one of the top reason why the companies are doing the software testing services. The testing of the software comprise of a bunch of projects. In case you find any bugs in earlier phase, fix them the cost and reduced amount of money. So we have to do the testing. And the next level as important is security. It is another crucial point why we are doing the software testing should be taken into the consideration. It is considered the most vulnerable and the sensitive part. There are a bunch of situations in which the information and detail of the users are stolen and they are used for the benefits. So we have to check with the security levels and then quality of the product. So when we are completing the testing, the software quality we can able to identify whether this product, that means the software, whether our software is fulfilled every requirements, everything is completed as per the requirements of the clients. So these and all will be checked in the quality of the product. And when we are completing this entire quality is getting more high, then we are ultimately satisfied the customer. So once we are satisfied the customer, then our company will be getting more growth. So this is a primary objective of the owner of the product, is offering the best satisfaction of the customers. Same like that in software also we are doing. The reason why we are necessary to option for the software testing is due to the fact of its offer, the pre-requesting and the perfect of user experience. Next one is enhancing the development process. With area of quality assurance, you can find a wide array of scenarios and errors for the reproduction of the errors. It is really simple and the developer need to fix the same in no time. So there will be, we have some certain issues. So we have to shut it up this problem. So next one is to understand whether the product has any undiscovered hidden features. Users are certainly not going to accept any product that has any sort of undiscovered hidden features. Hence, it is a prerequisite to performing any sort of software testing prior to insertion of the application and software for clients with an eye to detection of hidden errors. Determine the performance of the software. So we can able to determine how the software is performing to the user inputs. So it will be when we are giving an input, it may be getting some performance is reduced. So we can able to identify where we are lacking the thing. So we can able to find out thing. In accordance of with expert of not that important. However, in case you introduce any software in the market without testing, and after that the performance of the software does not meet the expectation and record of the clients, convincing the people will be hassle. So we have a lot of issues that when we are without software testing, when we are deliver the project, we have to do a lot of process for doing the proper way. Next one is the software testing techniques. So we are following a different type of techniques for doing the software testing. Already we know about why we are doing the software testing. So in the testing we have to check with the coding level, we have to check with the designing level, we have to check with the module level, and different type of testings we are using. So they can be classified and categorized in a number of ways. However, for the purpose of this article, we shall look at software testing levels and then software testing types and testing methodology. So we have to doing with 3 ways. First one, software testing levels. What are the level of testing we are using? One is a unit testing, integration testing, system testing, acceptance testing. So this will be deeply discussed with the next. software testing types. So the smoke testing, performance testing, compliance testing, functional testing, usability testing, regression, and then security testing. Next one is software testing methodologies. What are the way we are following for the software testing? One is ad hoc, agile, black box, white box, grey box. So these and all are testing methodologies. Now we are going to start with the unit testing. Already we discussed about the software in the designing stage. We are going to create a project. We are split as a module. That module will be having a small unit. That small unit will be tested in this point of area. That is a unit testing. Software application are comprising a various of block of codes. That may be procedures, or that may be function or modules or subroutine like that we are having. So that will be referred as a small unit. That unit will be checked. Like a small functions we are developed in the Java. That function will be checking whether that properly argument is receiving, they are properly working or not, that function will be returning the values, everything will be checked in this unit testing. So each unit of the software will be checking in this concept of unit testing. Next one, how unit testing is done. So already we discussed about small unit will be identified and then it will be checked. Okay, so we are having some certain phases, 3 phases we are defaultly following. First one, it initiates a small piece of an application it wants to test. So that is a testing, the software unit testing. Then it applies some simulates to the system. So we have to give some values. Then finally we have to check whether it shows whether it will be reducing, it will be giving a proper result or not. So that will be a small component of doing a unit testing. Next one, what should you not do the unit testing? Why some of ways we do not do that. So unit testing, that things unit testing is not about finding bugs. It will be checking whether it was properly working or not. So there will be we going to use with the unit testing. Next one is the integration testing. In this integration testing, in our mobile phone, example, above the camera app integrated with the storage manager. So that means we are having a memory card and we are having a mobile phone camera. So that both things will be connected when we are taking a photos to the mobile phones. That camera captured picture will be stored in our storage manager. So there will be connection with the thing. So same like that, we are having a number of units in the project. That small unit will be joined together. That will be coming under the testing of integration. So 2 or more module or 2 or more unit will be checked. That is a integration thing. System integration is defined as a types of software testing carried out of integrated hardwares. When we are doing with the different hardwares we are connecting and different type of equipments we are connecting to the software. So that time how it will be, both will be reacting. That will be tested in the integration testing. Next one is a small image for the integration testing. Different type of modules we are using, like a hardware, we are using some components as some other languages, web pages like that. Then types of integration testing. We are having a different type of integration testing, bottom-up integration, top-down integration, mixed integrations like that. We are having a lot of integration testing approaches. Next one is a system testing. A system is a combination of various units integrated together to carry out a function and task. So after completing the entire unit integration, we are going to check with whether the system is properly working or not. That will be a system testing. System testing ensures that all the units are used fully integrated and functions as on meeting that design function. So whether it was meet the task completion or not. So it will be checked in the system testing. So small image for the system testing. There will be a different type of module is there. That module will be checked within the system testing. Next one is a type of system testing. We have a different type of testings like a load testing, function testing, recovery testing, migration, usability, and software and hardware testing. So load testing is generally referred to the practice of modules, the expected usage of software program by simulating multiple users access the program concurrently. As such as this testing is most relevant for multiple user system, often one built using client server model such as a web server. Next one is a recovery testing. In this recovery testing, it will be checked with what are the things we can able to, suppose the software is maybe getting some crashed, then how we can able to recover the things, how we can able to get the existing already stored data, that will be doing in the recovery testing. Next one is a migration testing, is a verification process of migration of the legacy system to the new system with a minimal distribution and the downtime. So we have to do this migration testing. Next one, in the migration testing we are having some another one subpart. That part is a cloud migration testing. The cloud migration fulfill many business needs such as enhancing the operating efficiency, upgrading the customer experience, and allowing omni-channel experience as many more. There will be some basic thing is there, that is a on-premise tool, open source tools and cloud-based tools. These three tools which we are using for the cloud migration testing. Next one is acceptance testing. At this level, the software development, it will be checked with whether our value will be accepted or not, whether the value will be received by the new software, and whether it will be checked, the value thing, everything will be checked in the acceptance testing. Acceptance testing done by the user, customer and other authorized entities, those who are working with the software, going to work with the software, that will be come and tested in this software testing. Next one is the software testing types. So already we know about some of software testing like that. We are going to discuss with the first one, smoke testing. That will be built verification testing, where this testing will be tested in where the software is designed. Smoke testing lightly inspect most of major component, paying a particular attention to the proper integration. In this test is passed, the product produce the further testing. Next one is a performance testing. It will be checked whether the project, the software is performance and respectiveness of it will be sustainable when understand a certain load. So whether the value will be accepted and the task will be completed or not. Whether when we are giving a overloaded, that software have to work or not. How much thing it will be accepting, how much value it will be accepting. So like that it will be checking in the performance testing. Performance testing, we are doing some of few things like a split testing, stress testing, endurance testing. We can able to say it's a different words. Next one is a compliance testing. In this is to ensure that the software meets with internal and external standard policies and regulations. Where the software, like when we are doing the hardware, we have to do a lot of compilation testings. So it have to follow the standards. Then the next one is a functional testing. Test to ascertain if the software works according to its design specification and requirements. Unlike the system testing that checks everything, this testing is normally concerned with the output of the systems and not minding with the input and process carried out. Next one is a usability. In this usability testing, the user is most important element in the development of any software. This test examines how human factor and the user interface agree with the end users. Next one is a regression testing. Change and upgrade are any made of software continually. If we are going to do something and changes, so that will be as come into the new versions. That have to check in this regression testing. Next one is a security testing. Every software is liable to miscellaneous attack and intruders. Maybe hacking things also will be happen. So we have to do the security level of our softwares. So we have to check whether anything loophole is there or defect is there, vulnerability is there. So we have to check with that doing this software security level testing. Next one is a software testing methods. We are following the few methods for software testing. First one is an ad hoc, like it is called as another one way of recording as a monkey or random testing. So it will be checking a test carried out with no documentation or planning given. So normally when we are doing a testing, we are created a test cases. In the test cases, depending on the test cases, each testing will be doing. But when we are going with the ad hoc testing, it will be randomly checked. Suppose the module 3 will be started, it will be checked whether it will be given a value, different values, and it will be checked. Suddenly it will be going to the your module 1 like that. It will be not having any process, any documentation or any test cases. They will be randomly checking. That is an ad hoc methodologies. Next one is agile testing. A testing that ensures that ideals of agile software development are adhered to according to their manifest. There are various type of agile testings we are using, where the thing is that we are using a few methods. One is a behavior driven development, that is BDD, acceptance test. We can call it as an acceptance test. Next one is a derived driven development, that is like a additional thing. There will be acceptance testing with a driven development, ATDD. Next one is exploratory testing. There are few testing levels that can be used in agile: unit, integration, system, acceptance. This and all will be coming under the unit, agile testing also. The agile model, we know about the agile model, so just we going to see here why we are doing the agile testing. Agile testing for the projects of agile process model softwares. That the project is, we have to create one software and we will be doing all the process. After that again we going to start with the next level and then launching, like each and everything will be checked within the regression testing. Next one is a black box testing. It will be checking the behavior or how it will be working, like the behaviors. This is the testing of the entire system by persons who have no idea about the design, then structure and implementation of the software. It is tested for error in interface, performance, behavior, data structure and function, etc. The black box testing is a method of software testing that examines the functionality of an application without peering into the internal structure or working. So it will be doing in the black box testing. It is used in the system, again the external factor responsible for the software failures. So we have to check with the entire outbox of the black box thing. Next one is white box testing. It will be coming under into the like a depth level of testing, the programming level and everything it will be checked here. This is a similar to the black box testing, but it will be doing with structure level, depth level of class, function, methods and everything, how it will be working like that. We going to test in the white box testing. The white box testing is a software testing technique in which internal structures like functions, classes, methods, how it will be created, like objects, everything will be checked, and then design, how the module will be designed, how the form will be designed, how the tab will be designed, then and coding of the software, how it will be working, the functions will be working, like that it will be checked here. Then these things will be coming under the white box testing. Next one, benefits of the white box testing. So we already know about the white box testing. So when we are doing a properly in the white box testing, then the software will not getting any future discrepancies. So we can able to get it a proper efficiently we going to produce a software. Next one is a gray box testing. This is a final testing. The gray box testing is a combination of black box and the white box testing. So yeah, testing comprising of the two ideal of black box testing and the white box testing. Already we know about the black box, that is it will be as a structural like the testing. White box is a functional testing. So we combined and tested the gray box testing. The proper gray box testing is to search and identify the defects due to improper code structure or improper use of application. Next, the gray box testing is a software testing method which is a combination of both the white box testing and the black box testing. So here gray box penetration testing, whereas it will be coming to the new, and engagement that allow higher level of access and increase the internal knowledge falls into category of gray box testing. Gray box testing can simulated an attacker that has already penetrated the familiarity or has been some form of internal access to the network. So the gray box testing we are using a lot of areas. Next one is we're going to conclude our software testing thing. As earlier topics we are discussed different type of techniques and different type of software testings we are used. To the thing why we are doing the software testing means the major is we going to reduce the cost. So that is, it will be giving more productivity and it will be giving more profit to the companies. So thank you.